Let us compute the differences on the proneness to stress between male and female. So what we have here is the data that is in order for both male and female. Each group has the summation of x, or the total of all the data in a given group. Specifically, the summation of x sub 1 for male, and then the summation of x sub 2 for females. Of course, we also have the number of respondents in a sample, or what we all know as the lowercase n, and the total of all number of respondents in the sample size, which is the uppercase n. After computing the total of the given scores, the square of each score may occur, and lead to the summation of square of x sub 1 and the square of x sub 2. Now we go to computing for the mean of the samples, or the x with a line above it. To compute for the mean, divide the summation of x sub 1 to the number of elements in a sample, and same goes for x sub 2 in order to get the mean. Now we calculate for the estimated population variance for each condition in a sign of s1 squared then x. The formula for this is to get the difference of the square of x sub 1 and the square of the total of x sub 1 divided by the number of respondents. The answer found leads to the answer being divided by the number of respondents decreased by 1. The same formula goes for s2 squared then x, but only substitute with the data given in x sub 2 and square of x sub 2. Now to compute for the pooled variance, which is as s squared and pool, is to decrease the number of respondents by 1, and then multiply it to the estimated population of variance for each condition, and then add it to set 2, that has the same formula as set 1, and then divide it to the number of respondents that is decreased by 1 of set 1 and 2, and get their total. Computing for the standard error of difference, find the square root of the pooled variance that is multiplied to the total of 1, divided by the number of respondents in set 1, and 1 divided by the number of respondents in set 2. Now to compute for the t obtained for the two independent samples, subtract the difference of the mean of x sub 1 and the mean of sub 2 and the mean of population, and then divide the answer to the standard error of difference.
So the summation of scores of males is 223 and the summation of scores for females is 212. Next, we have to square each score and then get the summations of the squared scores. 3,665 is the summation of the squared scores of male variable, while 3,316 is the summation of squared scores for the female variable. Next, we have to compute for the mean of the samples. We just have to input the results that we just computed on the formula that was given earlier. So for the mean score of the male variable, we will divide the sum of scores, 223, on its total number of scores, which is 15, and the mean would be 14.867. And for the mean score of the female variable, we will divide the sum of scores, 212, on its total number of scores, which is 15, and the mean would be 14.133. Now, we will compute for the population variance for each condition. So for the males, we just have to input the value 3,665 on the summation of squared scores, 223 on the summation of scores, which then will be squared up, and 15 for the n, or the total number of scores. After that, we just have to compute it according to the formula, and then we now have 24.981 for the population variance of the male variable. Next, we will apply the same procedure for the female variable. Put the value 3,316 on the summation of squared scores, 212 on the summation of score, which will also be squared up, and 15 for the n, or the total number of scores. And there we'll have 22.838 for the population variance for the female variable. Next thing we should do is to compute for the pooled variance. Our n sub 1 indicates the total scores of male, which is 15, and n sub 2 for the total scores of female, which is also 15. Then we would also input the male population variance, which is 24.981, and 22.838 for the female population variance. After that, we just have to follow the mathematical procedures of the formula, and then we will have 23.9095 as our acquired pooled variance. Now we would have to find the standard error of the difference. Its formula requires the pooled variance, therefore we would input our acquired score of 23.9095 and also 15 for both total scores of male and female. Then we will follow the procedure of its formula, and then we will have 1.78 as the value of our standard error of the difference. Finally, we will be able to compute for our t obtained for the two independent samples. This requires for the mean score of each independent variables, therefore we will input 14.867 for the mean score of male and 14.133 for the mean score of female. As you can see, this formula requires the population mean of each independent variable, but since nothing is indicated or given in our set of scores or example, then we would just leave a value of 0 to it. The t obtained formula also requires the standard error of difference, hence we will input our acquired score of 1.783. After that, we would simply follow the mathematical procedure of the formula, and then we'll have 0.412 as our t obtained.
Since we are done with all the computations, we should proceed to the second and the rest of the steps to know which hypotheses we will accept in the end. Step 1. We should indicate our problem and form our null and alternative hypotheses. The problem begins in this step with the question being, is there a significant difference on the proneness to stress between male and female? Our null hypothesis for this problem would be, there is no significant difference, and our alternative hypothesis would be, there is a significant difference on the proneness to stress between male and female. For the second step, we would need to identify the value of df, the type of test, and the alpha in order to get the critical value. Our df will be 28. The given alpha for this problem is 0.05. This given example is a two-tailed test because it does not aim to know which independent variable is more prone to stress. Our critical value would be 2.048. This value can be found in the t-table, in which you would refer to the value of 28 as 0.05 alpha in a two-tailed test. For the third step, we simply indicate the t obtained that we had computed earlier, which is the value of 0.412. For our fourth step, we will determine which hypothesis is to be accepted for this problem. Since our critical value 2.048 is greater than our t obtained 0.412, we will accept the null hypothesis. And for our fifth and last step, we will indicate our conclusion that there is no significant difference on the proneness to stress between male and female.